says, we wish to determine the average income of all criminal law attorneys in Colorado. Okay, so we randomly sampled 500 criminal law attorneys from an attorney database kept by Colorado state government. From these 500 attorneys, we calculate the average salary as $42,000 per year. I think that's a little bit low, but who knows? And a standard deviation of 14. Okay, so for problem number 1 and 2 and 3, 4 and 5 and 6. All right, so problem number 1. What is the population mean? Well, the population mean is the 42,000 that they gave us. Okay? Oh, wait. I take that back. I'm going to say this is unknown. Okay, it's more of a parameter. It's unknown. Number 2, sample mean. The sample mean is the 42,000. Number 3, population standard deviation. That, again, is also unknown. Standard deviation. Number 4, the sample standard deviation is 14,000. Is 14,000. Okay, obviously that could fit onto a normal curve. We're doing Desmos, but we don't have to utilize that at this point. In a sentence, describe the estimate we are attempting to make here. So we're trying to figure out what the salary of these lawyers would be. Okay, and do we trust the sample we represent for the entire population? Okay, so the first sentence says, we wish to determine the average income of all criminal law attorneys in Colorado. So are we looking for all attorneys throughout the United States? No, we're just looking at Colorado. So we're safe to say that. And it's totally fine that we're looking at Colorado stuff. So we're trying. So do we trust the sample to represent the population? Hey, good to see you. Well, good to see both. We're in the. You guys were both here yesterday, right? Yeah. So we're on 5-1. We just started going to Thursday after work. Okay. So for number 6, do we trust the sample to represent? Okay. So it says we randomly sample. So they're checking a box there. Okay. That is the real important stuff. If you don't see random sample, I don't trust it. Okay. I'm pretty cynical on stuff, okay? And I kid you, you've seen my sarcasm and a lot of stuff. There are truly important go-tos for statistics. And if hey, triple, see you next fall. So if you are ever reading a study, if in your career you are at if you are looking at information, if you don't see that a random sample was listed, okay, as soon as I say a random sample, you trust it, okay? You let the bigwigs determine it if it was truly a random sample or if they're just lying about it. But they're saying that they did a random sample, and the thing is, they said 500 attorneys from a database were used. Okay? What was the number that I've kind of talked about yesterday? Is how many we want for a random sample. What's the minimum number I've kind of given you? What do you think? What do you think?
30.
30. Thank you. Okay, so is 500 more than 30? Yeah. I mean, 30 is kind of like your minimum value you want right now, unless we get to a T distribution. And then we have other ways of doing it, but we're not dealing with a T distribution. So right now, we're talking about 500 randomly selected people from a database. How do they randomly select? I don't know. They didn't tell us that, but they somehow had something in place to figure out how to get from our database 500 attorneys randomly selected. So these are all things. Do I trust this? Yes, I trust it because it told us it was random. It told us that they used 500 randomly selected people. Okay, this is all great. Okay, next one talks about IQ tests. We got. Oh, are you leaving this in?
Well, are you doing the one?
Ah, gotcha. Yeah.
Wait, so the difference between population and sample, so population is every single possible.
Everything. Every
So,
pot.
unless you count every single attorney in the state of Colorado, you can look at the population.
Right, and that would have to be. You would have to do a census. A census gets all the information from everybody.
Okay.
A lot of times, the population mean is something called a parameter. A lot of times, you don't know exactly what it is, but you could, because you have a random sample, you could start kind of saying, I am 90% confident that if I collected my data again using the same type of things, margin of error of plus or minus 5% on 90% and things like that is what the wording you use. So you never really know exactly. We will do confidence intervals soon, and that's you know when you watch the polls on TV and they're like, for elections, and they'll say, oh, the candidate A is leading by 54% plus or minus 6. So that's basically an 88% confidence interval. But you're never saying exactly. So you're saying, hey, we randomly sampled. This is what we think. This is where somewhere that ballpark's going to do. And that plus or minus is, the range that you feel that you confidently have your parameter would fall somewhere within that mean. And the parameter would then be the sample population or the entire population. All right, IQ tests are written and recorded in such a way that the mean is universally 100 with a standard deviation of 15. Okay, so let's think about this. IQ tests. IQ tests, somehow they have been able to figure out what the parameter would be, which is the sample mean. Okay, whether it's all done on the computer and the computer sits there and goes all together, there, bless you, perhaps there's a large amount of your population that does indeed do this. So they're saying that the population mean in this situation is 100. And then the sample mean they have, as we read a little bit further, it says a group of 1,000 psychology students at Northern Colorado take an IQ test. The mean of this group is 104. Okay, so there's some stuff that we just read about that we can probably say, I'm not going to trust this, but let's go on a little bit further. The population standard deviation, they were able to give it to us being 15. And then number 10 says the sample standard deviation, they said was 30. Oh, that should have been 104. Population center. Okay. All right. So we good so far? Does everyone feel comfortable with what I got? Did I make any errors? Because it's always possible. All right. So in a sentence, describe the estimate we might be attempting to make here. We're trying to maybe, so they're not real clear on what they're looking for in this, but maybe we're looking for Colorado IQ. Maybe. I'm going to put a little question mark with that because I'm not quite sure if that's truly what we're looking for, or are we looking to get the entire population, the population mean. Okay? Actually, population mean is not that. Population, I'll just say population mean. Do we trust the sample to represent the population? Explain why or why not. Okay. Is 1,000 a good number for our sample? Yeah. So this is good. This is a good number. Now, here's the bad. Let me reread the whole thing, make sure we got it. I'll miss some. IQ tests are written in and scored in such a way that the mean is universally 100 with a standard deviation of 15. A group of 1,000 psychology students at Northern Colorado take an IQ test. The mean of this group is 104. The standard deviation is 30. Okay. Do we see the word random anywhere? Like, this is not listed. Okay. This is just data. This is not listed. Okay. So a way that we might be looking at stuff like this is, let's say, I mean, they've been doing IQ tests for a long, long time. Okay, they not all of them have always been done on a computer. A lot of times it's pencil paper. But let's say they were able to take from, I don't know, the 1940s when IQ tests might have come into play. I'm just making that up. I don't know when it started coming into play. But maybe this particular psychology professor is realizing, oh my gosh, I'm getting a larger amount of intelligent students. I think that our students might have higher IQs. I think students now are developing higher IQs than they had in the past. That's maybe what they're looking at. Or maybe that person just had a good group of people that came through for a year or two or three or whatever, and that might have been a possibility. So do we trust this? It's random. The other thing that I don't trust is they're saying Northern Colorado. This is not national. Okay? So these are both really bad things about this study. I would toss this study. Now, my friends, I know I rip on the population as a whole. I don't rip on us because we're smart. Population as a whole, if you had the right media source get a hold of this and promote it, the rest of the population is going to believe it. But it's not statistically sound. That's a big danger that takes place so often in information. You get something, you see something on any of your social media, and it's like, oh wow, that's awesome. Okay. Again, I'm trying to point out your social media is an entertainment thing. A lot of times, if you see something, take a step back and say, well, globally, what's taking place? Okay, we have all seen propaganda that's been thrown at us because somebody's trying to sway our opinion. It happens all the time. You got to be very cautious with it because, a lot of times you start looking like a ding dong. My wife calls me on it all the time. I sit there and say, hey, I was reading about this today, and my wife is way smarter than I am. And she'll sit there and say, well, look at these studies I pulled up. You're wrong. It's okay. I'm married. I'm wrong all the time. So I can't ever be right. So my wife becomes my barometer on a lot of stuff. But I have told my wife, do not research anything about UFOs not being in existence. I love UFO stuff. I love it. That's my favorite thing in the world. I'm sitting there like going, what should I watch? And going through my streaming services. And it's like an inside look at Area 51 and the UFOs. Oh, dude, I'm watching. I mean, I love UFOs. Okay? And I will tell you, living in the state of Nevada for many years, there was times we would take motorcycles and ride out to the outside gates of Area 51, and you're just sitting there on your motorcycle, and there's a sign out there that says, do not cross this. We are authorized to use deadly force if you cross this line. But I will tell you, we've camped out by there, and there's some things we've seen flying that they don't look like the planes that I've seen doing flyovers at Bronco Stadium. So I'm convinced UFOs are real. And so I told my wife, like, do not try and disprove UFOs for me. That's my favorite thing. You can disprove everything else I talk about. Do not disprove this. And then my wife gets all upset with me because I think the moon landing was a hoax. But, you know, that's just who I am. But
You think it was fake?
I do. Why didn't we go back? We have such better technology now. I mean, we're supposed to go back in 26. I can't wait. We truly do. It's going to be incredible because the technology we have now, we're going to be able to really see it. I mean, they said the first person who was on the moon was Neil Armstrong. No, it was Neil Armstrong's cameraman. I'm just being sarcastic. What's funny is I was a few years ago, my wife had a whole bunch of her friends from Michigan in graduate school. They were staying with us, and we had the telescopes out in the backyard, and we're checking out all kinds of stuff. And I started telling them about my conspiracies about the moon landing's fake. And like, well, Chris, why do you think it's fake? I'm like, well, we have the Hubble Space Telescope in outer space right now. We also have the new James Webb Telescope in outer space right now. So why can't we point it at the moon and actually see the stuff we left behind on the moon? And Dr. Tim Stemler, I love him to death. He's incredible. I've tried to get him to come move here and teach high school. He's an incredible person. When you have a 6'8" hockey player who is a PhD chemist who teaches at Michigan, he doesn't fit in. He's not the normal PhD chemist. But he sent me all of these photographs of people with long-range telescopes bigger than mine that showed the lunar stuff. So I have to go back and recalculate my lunar landing stuff. I don't know. There's sometimes I like to say certain conspiracies just to kind of ruffle feathers of people. That's who I am. So I don't trust this particular one, or the last one. This one says the mean height of adult men in the United States is known to be 69 inches. My friends, I got to tell you, I am 5'9". I'm 69 inches tall. So I am the average height person. My friends, every one of you is taller than me. So you're all, I either teach amongst the giants or this is wrong. I have 2 close friends of mine that are shorter than me. Everyone else is taller than me. I'm the short guy in our group of friends. But it says the mean height of adult men in the United States is said to be 69 inches with a standard deviation of 2.5. We've dealt with this quite a few times. A random sample of 8 men at a local shopping mall showed the height of 67 inches with a standard deviation of 2.1. Okay, so we can answer these questions pretty easily. Anyone see any flaws in this one yet? What do you see? It's not national. What else? Sample size is too small. Now, later in this class, you could come back and argue saying that could be a t-distribution. We could deal with that, and that's an acceptable way to do it as well. But they're selecting people from a local shopping mall. Okay? So 13, our population mean. Our population mean, they say, is 69. Our sample mean, they say, is 67. They say our population standard deviation is 2.5. And they say that our sample standard deviation is said to be 2.1. And then number 17, in a sentence, describe the estimate we might be attempting to make here. We're trying to get to find if 69 inches is true average for men or something like that. Okay, do we trust this population? So sample size 7. This is bad as far as right now goes. Okay, we will see a t-distribution eventually. which allows us to start making these kind of characteristic changes, but we don't know that yet. Also, it says that it's random, so that's the only good thing about it. So random, I like this. So a random sample of 8 men, or it was not 7, but it was 8. Random was great, but you're at a local shopping center. Okay? So you might have been at a local shopping center by, Short Personville, Smallville. Okay? I'm just kidding. But do I trust this? I don't trust. No trust here. Okay? That'd be like you just walking across campus and you randomly sample 8 guys on campus who are seniors and find out what their heights are. And you can figure out the standard deviation because Desmos does it nicely when you pull it into a list. Okay. So number 19, explain the difference between a statistic and a parameter. A statistic is once you've gathered from your sample, you can find your mean and median. The parameter is often the unknown population mean. Okay? So the difference between a statistic and a parameter, a statistic is you collected data, you ran your data. A parameter is what the entire population mean might be if you don't know it. You're approaching to try to get to it, but you're not sure. Okay, number 20 says, we wish to take a random sample of students at CCHS, that's us. Would each method provide a sample we could trust to represent the population? Explain briefly. So, and I think we're talking about the entire population of CCHS, the roughly 4,000 students that are here. Okay, so we go into the cafe during 5th period and 6th period and ask students sitting inside. You gonna trust that based on the whole population? When was the last time you guys ate inside our cafe? Most of you are off campus, right? Yeah, so a lot of times the kids that are sitting in there are either the lower class, freshmen, maybe sophomores. You might have a sprinkling of juniors and seniors, but for the most part, you're not in there. I mean, even if you're staying on campus during lunch, you're probably not going to stay in the cafe. It's during 5th and 6th period. Obviously, we have lunch 4th period as well, so that kind of might be a bad thing. So I wouldn't trust A. And then it says, select 4 senior English classes at random and ask all students in those classes. Okay, so your entire population is the population of students at Cherry Creek High School. You select 4 English classes at random and ask all students in those classes. I trust that a lot more than going into the Creek Cafe. One, because you need 4 years of English. But is every kid taking an English class this year? Or did some kids already maybe double up? Maybe they got college credit someplace else. So is every student necessarily at Cherry Creek High School taking an English class? The answer is no. And I mean, we do have a population of our students that will never be in a traditional class like this is because they're learning disability or just disability in life. Okay? And that's kind of how that is. But I trust that. I think B is a much better representation than going to the cafe, but there's still flaws in it. And then put the name of every Cherry Creek student's name in a hat. Then pull out 50 names and ask the chosen students. I could easily generate an entire list of all of the students here at Cherry Creek High School. I could easily put all of those students' names on an identical sized piece of paper, and I could easily pull out 50 of them. Now, things about if you're going to pull 50 out, if you want to continue to keep it random, you need to have something that's churning all of those pieces of paper around between each grab. If you just say, I'm going to reach in I'm going to grab a fistful and I'm going to count out 50. That's not randomness. Okay? If you reach in, you're going to probably grab the same. Like if they came in here and said, okay, all students, write your name on this piece of paper, and we were the very last class, and we threw our names at the very top of the hat, and they never once shuffled it up, it's a very high probability that they're going to have a larger amount of students from this class that they're going to be able to sample. So this is a key. So things I've learned in life, because I've taught statistics so long, they often do this at our end of the year banquets. Okay, all of the teachers and staff that show up to the banquet, you take your little name tag that they have provided for you and you drop it in the box. I win every year great prizes. Now, am I just that lucky? I've learned how to cheat the system. Yep, I crumple it up and then unfold it, so now it's all uneven. So when someone's hand goes in there, I was like, oh, and Chris Stirrup, you got the $2,000 gift card to go eat at blah, blah, blah. Sweet. And we have some pretty good prizes that we can win. I won a Yeti cooler. It was a $600 Yeti cooler. I gave it to Mr. Lefebvre. I didn't need it. I won a nice 4-pack to a golf down in one of the golf courses in Castle Pines. I don't golf, so I gave that to Mr. Padovic, and he took Mr. Barons, Mr. Lefebvre, Mr. Peterson. They all went golfing on account of me cheating the system. I won, what else did I win? I won another cooler, and the nice thing about winning that other cooler is it was full of different assorted adult beverages. And they were in nice bottles, so that was good. What else have I won?
What do you not like?
I won a trampoline. That was kind of fun. But I gave that to a science teacher who left a few years ago. Sorry, they had a trampoline. I won. What else have I won? I've won money. They've given money out. They're like, okay, in this envelope, there's $500. This is a big prize. And Chris Strupp, $500. Yay. Yeah, that's a. But if you ever get your name in a raffle and you get your hands on the piece of paper they're putting in, crumple it all up, unfold it so it's like jagged edges, you'll be surprised. And they haven't caught on to me yet, which is beautiful. I enjoy that.
What does it happen?
It's right after your guys' graduation. All right. All right. We are actually going to go to 5-3. We're not going to do the activity. Sorry, I'm too cheap to have worked about M&Ms for you. Okay, basically, the M&M thing is to figure out. I mean, the gross thing about M&M thing is it's kind of fun doing the activity, and then you get that one kid after everyone's had their hands touch each M&M that eats the M&Ms, which is kind of funny. So let's take a look at 5-3 notes. All right, the sampling distribution of the sample mean. Let's see. I haven't read this since last year. It says, when the characteristics of the population are known, the sample mean of any sampling distribution can be modeled with a well-established formulas. Let's consider a specific example in which the population characteristics are well known. Okay, so the IQ has been constructed with a population mean of 100 and a population standard deviation of 15. Again, this has probably been put into a national database. I don't know where I could find it, but I bet you if you are in the world of psychology or psychiatry, you could find this particular test. If I select 100 people at random, okay, there's our random. We like this. That's in 100 people. That's way more than 30. I like this as well. Will the average IQ of this group be exactly 100? What do you think? I already know that the entire population has an IQ of 100 and a standard deviation of 15, if I randomly select 100 people from this particular list, or just randomly select 100 people, will my group have a mean of exactly 100? What do you think? So let's say there's 200 million names that they used to get the population mean and population standard deviation. 200 million is a lot of people, right? There's 330 million in the United States. So I'd say that 200 million or 200 million would be a pretty good amount of it. But even if I pulled out that 200 million at random, out of the entire United States, 330 million, I still might not get exactly to the 100. Okay? Are there things that happen by chance? Yes. Are there things that we need to look at? And then it says, it's highly unlikely that your random sample will produce a different average, only because randomness produces unpredictable results. It's highly likely our random samples will produce a different average. Okay? Because randomness produces unpredictable results. So sampling variability is the tendency to produce different results from a random sample to the next random sample. Okay, so like if I took the 30 people in this class, which is not a lot, but let's say I was going to try and figure out how much, I can't really say that, how much you have in your Venmo account. You guys don't use money anymore, right? Okay. Everyone, for the most part, use Venmo, though, other than this guy. Now, let me ask you this, because I don't know, because I don't use Venmo. You have money in your Venmo account, so if you clicked on your Venmo app, does it show you how much money you have? Yeah. At that point? Okay. And then you could say, oh, I want to transfer $10 to this particular person, and it basically does that person would show plus 10. Okay. So if I were to, let's just use the whole school as far as Venmo goes. Let's go out of this class. And let's say I was able to get everyone's Venmo account, and I can figure out the average amount of money that every person has in their Venmo account. So I have the average. If I go and I randomly select 50 people from Cherry Creek High School, let's say the average amount of Venmo, how much money do you have a Venmo account?
Yeah, but I transfer everything into my
Yeah.
account, so it's usually a zero.
Oh, it's usually a zero?
Because you can just transfer like the details right.
Oh, I didn't know this stuff. Yeah. Okay. So maybe I shouldn't use Venmo. Let's say I could ask every student who has to go home and ask their parents how much money they have in their bank account, just so you don't eliminate everyone with a bank account. And let's say we found out that the average amount of money people had in their, let's make it easy, was $20,000. Of all the parents here at Cherry Creek High School, I don't know, I'm sure it's different, but let's just use 20,000. If I randomly selected 50 people and then went and ran it, it's very unlikely that I'm going to get exactly 20,000. I'd probably get somewhere around 20,000. My sample might produce a little over 20,000. It might produce somewhere under 20,000. It would not more than likely produce exactly that. Now, it could. Yeah, you have a chance that you could do that, but there's variability that takes place. It's a tendency to produce different results from random sample to sample sampling. Okay? So when we were looking at some of these studies, if someone looked at a study saying, hey, I want to reproduce the study, it's very possible that when they do their own study, they are not going to get the exact same mean that the original study had and not the exact same standard deviation. And that's your variability. It varies from sample to sample. Okay, it's very unlikely that you would take one sample of, say, 30 people, and then do another random sample of 30 people, and do another random sample of 30 people. It's very unlikely you would have any of those three samples that would produce the exact same mean and standard deviation. Okay, and that's your variability. Assume that the psychologist finds that the random sample of 100 people and the measures their IQs, assume the average sample produce 102.2 and a standard deviation of 15.4. This sample differs from the population parameter simply because random sampling produces unpredictable results. This, in essence, is the sampling variability. So, does the variability make sense? Okay? It'd be like if I went and collected everyone's grade they have. Let's say I could find the percentage grade you had in math for all of your years that you took math, and I could find the average of that. And I took everyone's average, and I could say, okay, no, my population has an average score of, I don't know, 86.2%. If I went and randomly selected 100 people, 86.2% more than likely wouldn't be where my sample is. It might be a little bit above, it might be a little bit below. Being exactly there is kind of goofy to think about. All right. What time are we at here? 6. Cool. Why don't we stop there for today? Oh, hey, I need your homework from yesterday. Need your homework. And if anyone turn it in, anyone turn something else in? 5-1. All right, guys, want to make sure your name, first and last name's on it, please.
First and last time?
Just put Nate. I got you covered. You just put Nate. I'll figure it out. 5-2 or 5-1. Statistic is like when you look at a sample, you can get the mean and standard deviation. The parameter is the population mean. You don't always know it. You might get close to it. Any more homework out there I need to know about?
Or you can't
More homework I'm missing. I got it. Sweet. Does anyone still have their homework that I'm missing?